Hello everyone. Here is a recorded session for the numerical which is based on the our unit is optics. So let's start our first numerical. Radii of curvature of the two faces double convex is R1 area 10 centimeter, then 15 centimeter, this is R2. If the focal length of the given material, focal length is given 12 centimeter, find out the refractive index. Okay, in this given question we have to find out the refractive index. So what we have in this question is R1 is equal to 10 centimeter is given and R2 is equal to minus 15 centimeter is given. Okay, minus 15 centimeter is given because it is a convex, or the one side will be remain as a positive, which will be in the left hand side according to the sign Cartesian convention. Which side is the right hand side will be taken as a negative, positive, and which side is in the left hand side and the side of object will be taken as a negative radius curvature of the convex lens. And the focal length of the given curvature given surface is 12 centimeter. So we know that these components given in the question paper will be indicating that we have to use the formula for this refractive index find out is that lens maker formula. Okay, we will use the lens formula. So the what is that, we have 1 upon f is equal to mu minus 1 upon r1 and 1 upon r2. This is our formula. So straight away we will put the value of 10, 12 and minus 15 in this question, and we are able to find out the refractive index in this formula, lens formula. So after putting these value, our equation looks like 1 upon 12 mu जो कि हमें find out करना है, and then 1 upon 10 minus 1 upon 15. Okay, so these equation will give something like this. When we you can say that multiply with the minus and also take the LCM, it will be something like a LCM is 30 and 10 3 ja 3 and 10 2 ja 20, 15 2 ja 20, and it will be a plus because the minus will multiply with the plus, and we will get the 1 upon 12 is equal to mu minus 1. It is something like you can say that 5 upon 30. Okay, so we will 5, it will be cut it like this, and we will get that mu minus 1 is equal to something like you can say that 6 upon 12. So we will definitely get a value after doing this thing, this process. What is that? Mu is equal to 1 plus 6 upon 12. So we will easily subtract this one 2 times here also, and after side change the value, after doing all these functions, we will get the mu refractive index as a 1.5. okay, 1.5, or you can say that 1.5. okay, so that is our answer for the first process. Okay, so now our second question is two lenses of power 10D and minus 5D are placed in contact. Calculate the power of this combination. Suppose that we have to calculate the first power, and where should the object be placed from the lens that we can obtain the virtual image and the magnification, whose magnification is m is equal to 2. So first question is asking about the power. So what is the power? So we have two values 10D, and second power is given in the question is P is equal to minus 5D. Okay, so these two values of the powers, we know that the combination of power is something like this. It will be something like this, so on up to the value of Pn. So here we have the only two lenses are there, so we can straight away add these values. So 10 minus 5 with the symbol of the minus and 5, we will put it in above equation, and after subtracting this we will get the T. So our power is basically, the resultant power is 5D. So that is the answer of the first question, which is asking the combination power. Now we will move to the second part of this question. Where should the object placed? So in other words, we can say that we have to find out the value of u, because object distance is always denoted by the small u. So in our question, we don't have the focal length, so we know the relation of focal length with power is 1 upon p. So after putting the value of power, we will get the value 0.2 meter. Okay, so we can convert it like up 20 centimeter also. So by putting this value here, we can get the value of 0.2. Now we got the focal length. Focal length is about 20 centimeter. So lens is convex, so power remains positive. Okay, so power remains positive, and the magnification will give the relation m is equal to plus v upon u. So we have the magnification given in the question is 2. Okay, magnification is given 2. We will put it here in this, and the virtual image is formed. That's why it will be the positive one. Okay, because the image is formed virtual one. See in the question a virtual image there, so the value will be remain as a positive here. So after putting the value 2 from the magnification, m is equal to 2 is given. We will get the relation v upon u, something like this. So we get the value of plus 2u. Okay, 2u. So we will put this by using this formula, 1 upon f is equal to 1 upon v minus 1 upon u. So we have the focal length 20 centimeter, and we have the relation between v and u. We will put in this equation, and we can easily get that value. What are those values? I am doing here 1 upon 20 is equal to 1 upon 2u. In place of v, I am putting the 2u, and the u will remain as it is. So we can take the LCM here 2u. So 120 is equal to LCM 2u, and 2u, and above in numerator minus 2u. So that value will be minus 1 upon 2u equal to 120. So by cross multiplying it, we will get the value is 2u is equal to minus 20. So u will be divided the 20, and we get the value is minus 10 centimeter, which is our answer. According to the question, it is asking the where should the object place. So we have to find out the value of u, that is the value of u. Okay, so that is our second question in given numerical session. Okay. Yes, now our third question is draw the ray diagram to show the working of compound microscope and deduce an expression for the magnification when the final image is formed near the point. In a compound microscope, an object is placed between the distance 1.5 centimeter and the object length, focal length is 1.25 centimeter. If the eyepiece of the focal length is 5 centimeter, then the final image is formed at the near point. Estimate the magnifying power of the microscope. So what we have to find out, students, we have to find out the, you can say that magnification value. Magnification is m. So in this question we have to find out the magnification value, but initially we have to solve this equation is in the form of, you can say that with the value of draw the ray diagram. First of all, compound microscope का ray diagram हमें draw करना है. In the first line you will see that the ray diagram, first of all we will draw it. So what is that ray diagram? We will see it by drawing. We can easily, we have done this practice in the class and as well as in our online session. What is that ray diagram? That is something like this. So that is our ray diagram for this question, for you can say that microscope, or you can say that for the image formed by the microscope. So that is our ray diagram. We have earlier explained that there is a two lens, objective lens and eyepiece lens. An object is placed just before this objective lens. That's why it is called objective lens. And the eye is near to this second lens, which have the larger focal length. That's why it is called eyepiece lens. Okay. The distance between eye and you can say that final image drawn, least distance of distinct vision. You know that earlier we have discussed in class. Least distance of distinct vision, it may be the 25 centimeter. Okay, so that least distance of distinct vision is denoted by the capital D, and the remaining things will repeat. So the point is A dash and B dash of the object in the picture will be behave as a, you can say that virtual object for the eyepiece. Okay, but actually the object is placed at the point AB before the objective lens. Okay, so that is what we are having in this picture. According to the question, this question generally comes for the 5 marks for your coming subjective examination of term 2. So it is have the very large question. So that's the value of, you can say that this diagram is approximately 1.5 marks or 2 marks when we draw the label diagram. So that is the answer of first part. Now what we have to do, that second part is saying that deduce the expression for the magnifying power या टोटल मैग्निफिकेशन का एक्सप्रेशन बनाना है हमें. सो व्हाट हाउ वी विल do that magnification. We know that the magnification done by the objective lens is final image is, or you can say that object. So final image means to say that first lens ने जो image बनाई वो h dash है, यानी कि जो value है ये वाली. So that is h dash. So we can write it as a objective distance VO, और यू कैन से दैट इमेज की डिस्टेंस वी नॉट हमने यहाँ रख दी. तो ये जो एच आएगा ये किसके साथ आएगा, ये आएगा ऑब्जेक्ट की डिस्टेंस के साथ. ओके स्टूडेंट, यू आर इजीली एबल टू सी दिस वन. सो दैट इज द वैल्यू ऑफ द, यू कैन से दैट मैग्निफिकेशन फॉर्मूला. तो व्हेन द मैग्निफिकेशन इज ड्यू टू द आई पीस इज फाइनली ड्रॉन ओवर दिस सीट इज व्हाट वी विल, when the final image formed is near point, this one is magnification by the eyepiece is equal to 1 plus least distance of distinct vision. Earlier we have studied that d upon fe. Okay, so these are the two values. Okay, the total magnification, we have derived this formula in our offline class, is m, and m is equal to m naught into me. तो ऑब्जेक्टिव और आई पीस की दोनों की फोकल लेंथ हम रख देंगे. तो फाइनली वी विल गॉट द फॉर्मूला फॉर 1d अपॉन fe. सो दैट इज़ अवर फाइनल फार्मूला फॉर द मैग्निफिकेशन. ये हमसे क्वेश्चन में ड्राइव कराने के लिए कह रहा था. सो दैट इज ऑल्सो हैव द गुड वेटेज इन द क्वेश्चन, बिकॉज क्वेश्चन इज 5 marks. सो वी हैव द थर्ड क्वेश्चन इज देयर. सेकेंड पार्ट एंड फर्स्ट पार्ट, एंड थर्ड पार्ट is little bit numerical portion is there, which is given that u is equal to, see that u, what is the u in this question, u is equal to 1.5 centimeter and focal length 1.25 and eyepiece की focal length दे रखी है 5 centimeter. दो focal length दी है और एक object की length दी हुई है. तो u is equal to minus 1.5 centimeter, और हमें दूसरा जो दिया गया है ऑब्जेक्टिव की फोकल लेंथ दी गई है 1.25 सेंटीमीटर, और एक आईपीस की लेंथ दी गई है हमें, आईपीस की फोकल लेंथ दी गई है हमें, दैट इज़ 5 सेंटीमीटर अकॉर्डिंग टू द क्वेश्चन. सो बाय अप्लाइंग द फॉर्मूला फॉर द लेंस वी गॉट द फोकल लेंथ रिलेशन एज वेल एज द ऑब्जेक्ट इन इमेज डिस्टेंस बाय पुटिंग द वैल्यू 1.25 अपॉन v naught and minus 1.25 object distance. So we got the value of v naught. What is that value? By doing this, by changing the side and taking the LCM and doing it, I am just pausing it and doing the calculation. Final answer will come. So after doing the separate calculation, I got the answer 7.5 centimeter. 7.5 centimeter. 7.5 centimeter is a v naught. So we have done the formula here. यहाँ पर हमें v naught चाहिए, u naught चाहिए, दोनों हमारे पास हैं. लीस्ट डिस्टेंस ऑफ डिस्टिंक्ट विजन d 25 सेंटीमीटर होती है, ये भी हमारे पास है. फोकल लेंथ ऑफ आई पीस ये भी हमारे पास है. सो 1 हम इसे पुट कर देंगे और फाइनली हमारा जो मैग्निफिकेशन वो आ जाएगा. सो व्हाट इज़ दैट वैल्यू वी विल डू बाय दिस. Magnification is equal to v naught divided by u naught 1 plus t over fe. So by putting all these values and after calculating this, we got the final answer for the magnification, and we will score the 5 marks. 5 very question is there. I am just pausing the video and then calculating the part. So after doing calculation, we got the value minus 30. So that is our magnification done by this microscope, okay, with given these values. So our first of all our answer is what? First answer is for the magnification, first answer is for the picture or image, second for magnification formula, third for numerical value of magnification. So if you have any query or suggestion, please send me the message. Thank you very much for joining today's class.